All right, so hello everyone, and welcome back to the channel. I've got a really fun project today, which is creating a audio visualizer using React Native Audio API and React Native Skia. Guys, really quickly, you actually won't be able to hear the audio in this video, just because I don't own the rights to the audio that I used, of course, and I haven't paid for them. But if you download the code and you use the actual app on your side, you'll hear the music come through just fine. I just can't include it in the video. As always, guys, the sample code is going to be included in the description. The main branch is going to be the starter code if you want to follow along. And then if you are looking to just get the solution branch is always there for you. Okay, guys, so that's everything. Let's get started. Okay, guys, so as usual, I'm going to start with a little conceptual overview of things so that it makes it easier to understand what's going on once we start writing the code. Basically, in React Native Audio API, what we deal with is something called the audio graph. What I'm going to do is I'm going to simplify the audio graph into just what we need today to create the audio visualizer. Frankly, there is a lot of details to the audio graph, and we don't need them all for this video. So I'm going to condense this down to the most simplest parts. So to begin, we start with the audio base context, which is also kind of the audio context for our purposes today. So the audio context is important for a few reasons. And the first is that it provides key parameters for us, such as the current time, the output destination, and the sample rate. Another thing that's important about the audio context is it also supervises the entire audio processing graph. So everything that goes on is sort of under control of the audio context. So for this video, we're only really concerned with two types of nodes, and the audio processing graph controls all kinds of nodes. The only ones that we're really interested in here are the analyzer nodes. And in particular, the one that we're the most interested in is the analyzer node itself. And then the other one that we're interested in is the audio buffer. And this contains the audio buffer source node. Okay, so that was a lot of explanation for the first part. I promise things sort of pick up now as we go. That was sort of the biggest, most all-encompassing node. But the next one that's important for us is the analyzer node. So what the analyzer node does for us is basically it's an interface that extracts time data and frequency data, and it allows us to use it in order to interpret various different information that comes from the audio signal itself. Now, next in the chain, that's really important, is the audio buffer. And what the audio buffer does is it consists of an audio asset which has one or more channels. Finally, in order to finish things off, we have what's called the audio buffer source node, which is a mouthful. Let me zoom in so I can write a little better. And what this does is it actually represents the audio data in memory. So when we take this all together, we have our nice, really simplified graph. And this is not exactly the graph, how it looks in terms of how it's actually used, but in terms of what we're doing today, this is a good visualization. We start with the audio context, which gives us an analyzer node. The analyzer node then talks to the audio buffer and the audio buffer source node. And basically, the information that we need sort of goes up and down this chain, just like this, so that we're able to then use it in order to create our graphics that we show to the screen. But all right, that's everything. Let's get started with some code. All right, guys. So as always, this project comes with a little bit of boilerplate code. If you want to follow along, you can just go into the main branch of the repository that I'm going to link in the description. If you just care about the solution, though, I'm also going to have a solution branch available for you, and you can look there as well if you just want to see all the code working. Really quickly, one thing you're going to have to do before you get started, I use React Native Skia here and React Native Audio API. So this will not work with Expo Go. You will have to do an npx expo pre-build, and that will give you a pre-build version of Expo, and that's the version of Expo we're going to be using. So don't try to use Expo Go. That's a bit of a gotcha here. Make sure you do npx expo run iOS, and all of this will work for you just fine. Other than that, Things are quite simple in terms of what we have. This info here is just this stuff at the bottom. It's kind of uninteresting, so I didn't bother coding it all out. You can see if I comment it out, we lose these little indicators. We're going to be spending most of our time today in two places, and one of these places is the use audio player hook. As you can see, I already have a song here. Unfortunately, you probably won't be able to hear it during the YouTube video because I don't want to get like copyrighted or something like that. So you're going to have to kind of trust me that the music is playing as we go, but I promise you that it is playing. You might be able to hear it a little bit in the background, but I can't make it super, super clear. I have to kind of make sure I cover myself here. Anyways, inside of Use Audio Player, we're going to be filling in the methods for draw, handle play pause, getting the playback time, getting the percentage complete, and then actually loading the music itself. You'll see I have a lot of empty refs and default values here. Those will all come in handy a little bit later, but for now, they're all just set to basically null or false. The last thing that I have here for us is the frequency chart. This is a Skia canvas, and we're going to use this in order to create the actual chart that we're going to work with as we go. All right, so the first thing that we're going to do is we're going to go into the audio player, and we're going to load the video. In order to do this, we first have to check that we have a audio context ref. If you remember from the earlier explanation, we need that in order to create the graph. And if we don't have it, we are going to create it. And then once we have that, we have to check if we have an analyzer ref, because that's also an important part of the audio graph like we talked about earlier. And if we don't have one, we're going to create it. And then we're going to get the analyzer from the context. Next, what we're going to do is set the FFT size. And the FFT size is basically the quality of the frequency and how much of the frequency that you're actually going to read in at any given time. I picked like a moderate number. I have a constants file here. I'm using 512. This has to be a power of 2. You can make it more or less depending on how detailed you want to be. But to keep things easy, I kept things to 512 today. Next thing I'm going to do on here is set the smoothing time constant. This is really just for animations so that the data being read in isn't too abrupt. 0.8 looked good to me, so that's what I used, but it's really kind of subjective. Last thing I'm going to do is I'm going to connect my analyzer ref to my audio context ref. And that should sort of initialize at least the graph that I need. The next thing I'm going to need to do is actually fetch the buffer. And the way this works is that I'm going to set is loading to true because I'm now fetching my music from the internet and loading it into memory. I'm now going to need my audio buffer ref. And I'm going to give this the music, like I said. And then I'm going to grab the response and get the array buffer from that. And then with the array buffer, whoops, I'm going to take my audio context ref that I'm sure exists at this point, and I'm going to decode my audio data from the array buffer. And this is, of course, an async function. And why is this yelling at me? Oh, and it's yelling because I put brackets in. Okay, once that's done loading, after the await, I'm going to set is loading to false because, of course, we are done loading at that point. I'm going to call fetch buffer so that we actually get the data. And I'm going to finish off by closing off my context ref if the component unmounts. All right, so now that we've loaded in our audio data, let's go to the draw method. And the draw method itself actually doesn't draw anything. What it does is it updates all of the data that we need in order to draw. And every time we call this, it'll do a re-render, and the re-render will tell Skia to redraw. The relationship between these two will be maybe a little more obvious when we work with Skia, but know that the main point of this draw method is really just to update our data so that Skia can draw. So the first thing we're going to do is make sure we have an analyzer ref, because if we don't, we just want to return. If we do have an analyzer ref, what we want to do is get the array length of our frequency data, which is the frequency bin count. We're then going to need a frequency array, which is going to be an unsigned int 8 array. And it's going to be of length frequency array length. After that, we're going to need to populate that array with values. And the way we do that is we call this method getByteFrequencyData with the frequency array. So this fills it in. So just to summarize really quickly, this line gives us the length of the data that we're going to get from the library. This creates the array, just empty though, with no values. And then this line here populates the array with all of the frequency data from React Native Audio. Once we have all that data, we're going to want to set state with it to the frequency array. And then the last thing we're going to do is we're going to do request animation frame. And in here, we're going to plug in the draw method. So this is recursive. The draw method's going to be called infinitely, but that's because every single frame that the music is playing, the frequency array is being updated. So on every frame, you have to get the data and then redraw. Okay, guys, so now that we have draw, there's a couple more methods we need. Then I promise we can get into actually drawing things with React Native Skia and making it look cool. The first one that we're going to need is handle play pause. And this one I think is maybe the most intuitive one we've done yet. So basically, if the music's already playing, we're going to take our buffer source ref and we're going to just stop it. Because of course, we don't want it to be playing. The pause time ref is going to be equal to 0. And finally, the start time ref is also going to be equal to 0. So if we're not playing, obviously we're in some sort of a pause state. So here we're going to check and make sure we have a audio context ref, because as we know, we need that to do anything and everything. Or if we don't have an analyzer ref, same kind of problem. Oh, what did I do here? Oh, I used the wrong bracket. But if we do have those things, what we're going to do is we're going to take the buffer source ref, and we're going to go to our audio context ref and create a new buffer source. We're then going to take our buffer and make that the audio buffer ref. And then we're going to connect it to the analyzer ref so that we can get data from it. Finally, the last bit of this is pretty straightforward. The start time ref is going to be equal to the audio context ref, it's current start time. And then the buffer source ref, we're going to start that. And then we're going to draw, because we've just made some kind of meaningful update to the data. And of course, we wouldn't be done unless we were to set playing to be true. And we're just going to set the state of his playing to be the opposite of whatever it was before. Okay, so the last thing we need before we can do some drawing is the current playback time and the percentage complete. And they're sort of codependent, so I'm going to create these two together, starting with the current playback time. So first thing I need to know is if there's an audio context ref. And if there isn't one, we're going to return 0. In the case that we do have one, we're going to check if the music is playing. And if it is playing, we're going to return the paused ref time dot current plus the audio context ref dot current time minus the start time dot current. This makes sure that no matter when you started or paused or whatever, the time will start from the place that you stopped last. Otherwise, if it's not playing, we're going to return the pause time ref value. So now in percentage complete, what we have to do is we have to get the current playback time and then divide it by the audio buffer ref current value dot duration, and we're going to just default that to 1. All right, so at this point, we should have all the business logic that we need. We have the is playing, is loading values that we set when the values were loaded in the use effect. We have the frequency data, which we grab in the draw method. We then have the play pause method, which we started here, which controls what happens when the music starts or stops. And finally, we have the current playback time and the percentage complete, which is what we just set here. All right, guys, so before I start the next section, really quickly, it's going to get a little bit quirky. And the reason is when we draw the bar chart, we have to deal with the fact that we have a massive amount of data. So the bar chart, let's say we have 2 axes, just kind of like this, right? We have way too many bars because there's just so much frequency data in any given audio clip. So you would have like, I don't know, a whole bunch of bars just like this. Let me just draw a whole bunch here for us so that I have a whole bunch of data. And really, there's like 256 of these, right? And there's 256 because we set the FFT to be 212. And so on its face, this is a little intimidating because it's like, how are we going to get this data on the screen, right? Luckily for us, the data is arranged in a pretty logical way. So, maybe these few bars are the bass, these few bars are the mid, and then the final bars are the treble. So what you can actually do is you can just sort of create little sections and then take an average of the value in each given section and just make that into like 1 bar per section instead of having like 256 bars. You break it up into smaller sections and then you create bars for each of those smaller sections. And that's what we're going to end up doing here. So it's going to be a little bit slightly complex logic, but I don't think it's too bad as long as you keep in mind this chart here. All right, guys, so let's finish up with the fun part, which is actually drawing the bars. Back in our app.tsx, you'll notice that all these values from the audio player, or I'm sorry, the frequency values from the audio player are passed into the frequency chart. And that's what we're going to use in order to actually draw everything. In here, if you remember, we have some simpler boilerplate, just one to get the size of the Skia canvas, and another one to just grab the data out of the props. Of course, nothing really all that complicated here. First thing we're going to need in order to be able to draw our bars is the width of each individual bar. And we're going to get that by getting the width of our Skia canvas, dividing our FFT size by 2, and then dividing it by the number of groups that we want. And I'm going to subtract 5 just as a little buffer. By the way, the number of groups I'm going to divide it into is there are 256 bars, and I'm going to divide each section of 32 bars into a single bar at any given time. All right, so at this point, the next thing I need is to be able to plot the points on the actual bars themselves. In order to do this, I'm going to do it in a memo. And then the memo is only going to update when the size, data, or data size changes. And in here, I need to create a point array. And in the end, we're going to end up returning that array. So I'll just do that now. I'm going to need this running total value for averages. So I'm going to set it up here. And I'm going to have a nested for loop because, like I said, this whole thing is kind of divided into little chunks. So I'm going to say let I equal 0, while I is less than the FFT size divided by 2. I is going to be incremented by the group quantity. Next, what we're going to do is we're going to let j equal I, so wherever I currently is. And while j is less than I plus the group quantity, we're going to increment j. And inside here, what we're going to do is we're going to take our running total and add the data to that. Because remember, this whole thing's basically just an average, right? Like it's not anything more special than that. So to take the average, we're going to divide our running total by the quantity of the current group, which is always equal for every group. And we're going to say the x value is going to be equal to I plus 1 divided by the group quantity. So that'll give us the offset on the x-axis, how far we need to go. Y1 is going to be equal to the height of the canvas. And Y2 is going to be equal to the actual height of the bar itself. So we're going to say size.height minus size.height multiplied by the average divided by the FFT size divided by 2. The color of the bars is just going to be black. Just think it's a cool color. And then an array of points, we are going to push as x1, the value of x we created, y1 is going to be equal to the y1 value. Y2 is going to be equal to the y2 value. And then x2 is also going to be equal to x. And then we're going to reset the running total at 0. And I see I made a mistake here. I forgot to add the color. All right, so there we go. That's all of our points. The last thing we need to do is inside the Skia canvas, we're going to map over these points. And we're going to have the point and the index. And inside here, we're going to create a rounded rectangle where its radius is going to be equal to 10 because it looked nice. Key is going to be equal to the index. X is going to be equal to our point dot x1. Y is going to be equal to the point dot y1. The height is a little more complicated. I'm going to give it a minimum just so that it doesn't drop to like a weird level. So we're going to say point dot y2 minus point dot y1 multiplied by 4 and then negative 10. Oops. The width is going to be the bar width. And the color is going to be the point dot color. I probably could have hard coded that to black, but that's fine. That's where we're at now. All right, and you might be able to barely hear the music. I'm not really sure. I'm going to turn up my volume, so hopefully you can, and all this should work. And as you can see, we now have the music playing, and we're able to get the nice bar chart along with it. All right, guys, I don't want to play that too long because I'm going to get in trouble because I don't own the rights to that music, but that's this project here. I hope you guys enjoyed it, and I hope you'll be able to make some fun, nice experiments on your own later on. All right, that's everything, guys. Thank you, and happy hacking.